concepts we've learned so far are sufficient for you to dive into Elm or JavaScript. Mm-hmm. Mm-hmm. Cool. So the problem. Okay. Don't think that this is gonna copy well in here, but let's find out. That's pretty close. Okay. Let me just build this once, and then I think it should be good. LSP is a little finicky. Okay. So we also have a function for getting directions, like get directions. Given an address, this will return driving directions. The implementation details aren't important here. Let's also assume that we have the following data types. Person, company. We might want this. I'm not really sure. I'm not 100% sure of how deep we're going to go, so might be nice to have this information. Oops. Okay, so we have all that. So how do we get directions for each of these types? So we have like nested addresses and then like addresses as part of sum of products. Yeah, and then we're like unrolling them to see some examples of these things. Mm-hmm. Yeah, and then now we have to start writing functions like this. Yeah, I would probably write it in this style just because that's my typical preferred. Well, no, probably not. I would probably write it like this because there isn't a single case match. Not sure I would write this though. I think I would still write case underscore of. Yeah, like this is probably the style I would write for the residence example. But anyway, or where did you use the word or? Okay, I'm assuming that this is trying to say that this is one way to solve the problem, but I'm not 100% sure. So we'll see. Yep. And then we just like pull out this thing and then we use each of these. Oh, I don't like this at all. No, we shouldn't feel good about this. This is kind of a nightmare actually. Yeah, and then every time like anytime you come across something like this, you have this weird issue. It seems like we can do this with well, you can't quite do it with row types, right? Because you have address at the top level. Yeah, like if you were trying to write a function um get directions. Seriously? Go away. If you're trying to write get directions and you have the address, then it's problematic. Um but we'll see. Okay. Anyway, it's kind of an aside. Yeah, this is kind of miserable. Yeah. Okay. So yeah, you can see how this gets out of control. Like if you wanted to do that style, um, hopefully. Okay. So here's a type class. And like in other languages, you've probably heard of this as like a an interface, or um, I think Swift calls them protocols. Yep. So this creates the type class. We call it has address because it needs to have some kind of address. It may just be an address, or it could be like something with an address, like residence or company or person. And then we can write instance. So this is something that differs from Haskell. It's the syntax here. Should have just started that. Okay, so the syntax changes a little bit from Haskell. In Haskell, you don't have this name. I I don't know what this is exactly called. One, yeah, named. That's cool. I just guessed. The idiomatic way to name the instance is to use the type class name followed by the type parameters. So it's has address person in a specified order. Yeah. This requirement has been removed in PureScript 0.14.2. Wait, what does that mean? Um, okay. So what does it mean that this has been removed? So let's look at this because I'm very curious about this. Um, I don't know what that. Okay, now we can do that. Bring this over here. PureScript 14.2 changes. Oh, you can just declare them like Haskell. Okay, well, you beat me to it. Okay, so then in theory, we can just literally. Well, actually, let's leave this. And then we'll say less than pers 14.2. Six. I just want to see if it builds. I mean, I kind of trust that you're not lying to me, but oh yeah, look at that. Very cool. I didn't know that. That's super convenient because sometimes these look really awkward, in my opinion. So that's pretty nice that they got rid of those. Um, I suppose if you're just building this anyway, like, then you can easily just like build it based on this. Most of the work's already done for you, I guess. I wonder what required this. Like why this instance name was required before. Anyway, so that's kind of cool. The syntax highlighting is a little wonky, but I guess it's pretty much the same down there, so it's fine. Neat. I did not know that. Okay, so then you could write like all of these instances. Most of them are just pretty trivial. These ones are, I guess, slightly more complex, but not really. Um, okay, so if we now want to write get directions, we have to say for all A has address A, and then directions, whatever that is. So let's just make what am I doing? I don't understand what button I'm pressing right now. Type directions unit. Like we don't actually care what the implementation is. That's kind of the point. Um, well, I guess actually let's actually just write address. So because we don't have like a directions type, and like I don't really have a dot 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 in mind, I'll just say that this is a has address to address, and then we can just say that this is a get address. Unknown type. Oh, this is supposed to be an equal sign. Oh, sorry. We need to take something, like we need something that has address, otherwise we'll not be able to run has address, the get address. So anyway, we can imagine like a um a let address in, and then doing something to generate directions, which is fine. um you know yeah, I don't think I need to write a comment here. So this is, just how you use has address to like pull that out. Okay. I've seen constraints before, so this isn't new to me, but we'll see if there's anything else in here about constraints that are interesting. We've told the compiler that this A right here, can be any type, yet we're using A as if it has an has address instance. We need a way to let the compiler know that A can be any type, but it also must have has address instance. We do this with constraints. There's the constraint that we wrote. Um, type A must have instance of has address. Details, yeah, these dot dot dots aren't really important. I just wanted to get something that compiled. We can have multiple type constraints. So here we're saying that the thing must be showable. We haven't talked about show instance up to this point, I don't think. We probably have, otherwise you wouldn't have shown it. But show just means that it's like printable. So like you can write show thing, and we can print it somehow. It basically just turns an A into a string. Yeah. Okay, yeah, this is probably the preferred way to write constraints, I suppose. Although they tend not to line up as nicely. Like when you use the fat arrow every time, like you can write them on multiple lines. Yeah, like this. I think people tend to write in this style in PureScript, but I've not read that much PureScript code, so just keep that in mind. Okay, so yeah, here's the full example. It looks like. So now if we want to add the company, all we need to do is add the instance, which I have up there. So has address company where, and then get address company C address, like so. Yep. Cool. Okay. Um. Mm-hmm. Yep. Yep. All right. So every type class function is called a method. Get address is the one and only method of has address. Don't conflate this with object-oriented methods. While the words class and method are used, they have different meanings here. There's a requirement for type classes that may not be obvious at first blush. Every type class method must have its polymorphic parameter in its type signature. So what that means is this A needs to appear here, I guess. Oh no, just its type signature. So I think it's just here. Zombie Killer, thanks so much for the follow. Appreciate it. Are you sort of interested in pure script or just like what I'm doing? What do you like to code, or what are you familiar with? You don't have to answer any of these questions, by the way. Just I like to increase dialogue with chat if I can. Okay, so if we look back at our class, we see that each method, all one of them, requires an A as one of its parameters. So that's this A here. If we write this, apparently this is a compiler error. So again, I'm maybe jumping the gun here, but if you have type classes like this, where you need to fix A, but you don't want to put an A here, I think people would typically just put a proxy, or they would just like ignore the input and do something else. So like you could just put an underscore here and then ignore it. Excuse me. I didn't know that this is a requirement. Is this a requirement of Haskell as well? I can't remember offhand. Um, I think you in Haskell you would just use a type application to fix A for get address, but I'm not 100% sure. How would you do that though? Because this doesn't take an A. So I think, yeah, I will think that this would fail in Haskell as well, but don't quote me on that. All right, so built-in type classes. There are many built-in type classes. Most of the ones we're going to look at have equivalent, if not identical, versions in Haskell. So EQ or equal. This type class is for comparing two values of the same type for equality. So we take two A's and we determine whether or not they're equal, and then we have our infix. So priority, the function, like the, I don't know, binding keyword, and then what you want to bind. It has no associativity, which makes sense. Okay, so we can write instance eq person where eq. Can you write these like this? Person p1 equal person p2. Unexpected. Okay, it's not able to do that. So maybe we need to write eq. I suppose that makes sense because of the way that operators are bound, right? Like if this isn't bound inside of eq, whereas in Haskell, I think that this is just literally equal in single parentheses. So I think it makes sense that you can't write this at inside of the type class, only outside, which is kind of unfortunate, I guess, but it's fine. Um, so where is Okay, so p dot name, or sorry, I guess p1 dot name, p2 name. Put this on the next line because we're already running out of space. I forget what there is. Age. There's probably a generic instance of eq here that we could use, but I'm not sure how to do it. Maybe they'll talk about it here in a second. But anyway, this is where the problem will ensue. I think that this should fail. Why doesn't this fail? How does it know what an address is? I don't understand. Is it because it's a record of strings that it understands what it's doing? Let's see. So now we're stuck. We need to determine what does it mean to be the same person. Yeah, this is basically what I wrote. Okay. So a record has an instance of eq probably if all of the fields have an instance of eq. Okay. So this works because this is a type. If we make this instead a data, then I think that this will fail with the error that I'm expecting. Why? Yeah, because we don't know how to compare addresses. So that makes sense to me. I just wanted to like confirm that that's true. Well, it makes sense to me now. Did not make sense to me a minute ago. Okay, so we lucked out here. We didn't have to make any of our type fields an instance of eq because they already are. However, that's kind of funny that if we made it a data, then it would cause this error, and then we would have to define like the addresses. And because the addresses are just records, you can just say A1 equal AA2 like that. Cool. So actually, doesn't that just mean that we can write P1 equal P2? And that should just work because these are just records of things that all have instances. And it is true. Cool. So let's write a note here. Because P1, P2 are just records of things with eq instances, we can simply compare them. Cool. How you spell unnecessary? No. One C, two S's. I always spell that wrong. Okay, cool. So that's pretty useful information. Okay, ord. So type classes for determining the order of two values of the same type. Here's a definition. We take AA and we turn it into ordering. So it looks very similar to the eq instance, other than this being an eq, or sorry, a boolean versus ordering. And then here's an ordering. So things are either less than, greater than, or equal to. And then this is the part where it differs from Haskell, is the constraints here use this less than or equal, and in Haskell they use greater than or equal. Okay. Eq is a superclass of ord. This is not like inheritance. It simply means that any instance of ord must also be an instance of eq. So I guess that's kind of a nice way to put it, is like this, it being a superclass is kind of like greater than, or well, less than ord because it's less specific. Like ord is more specific than eq, I guess, is what they're trying to go for there. Okay. Most primitive types have ord instances, in other words, Boolean int string, but there are a few odd ones: unit, void, and ordering. What would the instance for unit look like? Try it without reading any further. So yeah, unit will always just be equal because there's only one occupant of unit. Mm-hmm. Okay. What about void? So void has no inhabitants. So I think it should just probably error or not exist. Oh, well, I guess they're the same in some respect. Yeah, I mean, I guess that's fine. Like, you can't ever observe a void. I've never once used a void, I feel like, for any real use case. I'm trying to think if I can come up with an example. I really can't. I use unit often, but I've never used void purposely. Okay. So ordering. Think about logical ordering for less than, greater than, or equal. What order would you put these in? It seems to me the most logical order would be that less than would be less than all other values. Greater than would be greater than all other values. Yeah, I mean, like, less than and less than are equal. Yeah, these ones make perfect sense. Um, Equal is greater than less than, and equal is greater than. Wait. Eq is greater than less than. Eq is less than greater than, and greater than is greater than everything else. And that's just the ordering. With megaparsec. Um, I'm trying to think if I have. I I can't come up with the obvious example, but cool. Megaparsec. I've used megaparsec before, but I don't remember using void offhand. All right, so we're gonna write an ord instance apparently. So let's just do that real quick. So instance ord place where ord, or sorry, compare when supplying a type for custom type error. Oh, here, look at this. Uh, Copy link. So you're like feeding it bottom such that you can get the custom error or something. Oh, this is void because there is no custom error component. No, no, you're fine. Um, that's a good example, I think. So this would say, this is like saying you're defining a parser type that's the parsec monad without a custom error component, right? And then like whatever you're trying to parse. And you would define this inside of your library or whatever that you're trying to use. I think. No, that totally fine. Distract me whenever you want. So, oh wait, yeah, I'm doing this backwards. So first in anything is greater than. Third. Well, I guess we should just compare them. First and first is eq. Oh, these are both capital, aren't they? Okay. Um. Okay, and then just was this complaining about? Oh. Um. So instance eq place where um man, I cannot type today. Just the morning typically. Okay, so this has unreachable cases. What? Oh, I guess that's true. That has to come first. Okay. And then if first is the first thing, this can only be third, and third in anything else is less than, I guess. I think this is probably right. We should test it, obviously, but we're not going to do that. Okay, so we have, yep, we have the same instance here. And third, second, and anything. Wait, what is this? I feel like this is backwards from the semantics of first, second, and third. Like third place is not as good as first place. Anyway, I think it's fine, but it's kind of weird. This doesn't actually get this case. Well, no, then it doesn't matter. Okay, so I think we just missed that case. Anyway, I feel like this is semantically backwards, but like, again, you can define this however you want. It's semantically backward from what I'm thinking about. All right. So then apparently we can also do actually I should just do this up here because what is this complaining about? Is this just part of Prelude? I don't know where that is. Here's, oh, it's a raise, plural. There you go. Do, do, do. Nope. Okay. Of course. Oh, okay. I always forget that that's a thing. I always just write it. Yeah, I mean, I guess I don't really want to, but I always forget that I can do that. So I just edit it by hand. Um, I know there's a way to do this generically, but I don't remember what it is. So I'm just going to do it like this for now so that we can hopefully reload and then do that. Yeah. So there we go. So here's a way you can um, implement a show instance. It's not like beautiful or anything, but there it is. Okay. So we notice A is constrained by ord. It must have an instance of ord, which place does not. Without it, sort couldn't decide which element of the array goes where. You can also use your type, our type, as a key in a map because it has an ord. Okay, ordered collections. Here's the show. We were talking about this earlier. Yeah, we just implemented it this way. Again, this syntax is available in PureScript greater than 14.2, which was mentioned in the book. Just saying it out loud again. Um, mm-hmm. That was painful. It was nothing but boilerplate. Da, 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 da. Yeah, and then okay, so here's the sort of deriving. I'm hoping that we can just write eq some type, but maybe not. If they no longer have to be named, it seems like this should work. Make Spago build. Um, 86. Oh, I seem to have clobbered something that I had existing. That's fine. We'll just write it down here. It seems to not be complaining, and yeah, it doesn't. Cool. So prior to 14 point, this would require a name. Neat. That's pretty cool. Um, it's also nice that that's consistent, so we don't really have to think about it. But what about show? Yeah, so show, you can do the generic bits, generic rep, class, generic. Data, show, generic. Okay, and then place, or sorry, we're doing this for some type. So we can say derive instance generic some type. And then instance show some type where show generic show. Okay. Sorry, I missed this. Kind of a hard to see over there. But this is a little tricky. I guess it's like I don't fully understand this right now. But I haven't worked that much with generics. Maybe it'll be explained here. So you can see there's a lot less typing here, which is really nice. Okay, so we can derive the generic instance for our type. In fact, we can only derive this. We're not allowed to write our own instance. This guarantees that the internal representation is done correctly. This is also why the second type parameter to the generic type is underscore. The compiler will fill it in its type to guarantee that it is to correct. Interesting. Okay, so this is just to prevent you from writing your own instance. That's interesting. Like you can't derive an instance for this because you can't actually fill in that hole is the idea. It's not a hole, but pretty wild. I didn't know that. So you can't write your own generic instance. The underscore is filled in by the compiler. Very cool. Okay, and then we can just use this generic show. I think there's other versions of this, like generic or generic eq as well, but you can usually just derive them. I can't think of obvious cases where you can't. Yep, so then we could just do the same thing for place, and then we could replace this this nasty instance. I think we can also just replace these instances as well. Although if we wanted to do it the way I have it, we'd have to flip this order. First would have to come last, I believe. The generic instance, or sorry, the deriving ord, I think puts them as this is the least, and this is the most. But we're flipping the semantics there. Okay, new type class. Yeah, so it doesn't really say this, but a new type, the whole purpose of a new type is to provide a name for a type that already exists that requires you to use this constructor. So like you have two options. You can write, I'm surprised this isn't explained here, but maybe it was explained earlier and I just don't remember. Okay, so you have two options. We can either do a new type like this, or we can do a type alias. Sorry, this is supposed to be a string. Okay, so the difference here is that first name and string are completely interchangeable. So like anywhere you could take a string, you could also just place a first name. And so you lose a bit of type safety there. So that's what this new type is for. It basically just provides a name, like a data constructor for you to access this string. And you can't like swap in a string without first wrapping it up or unwrapping it if you have to pass it to some other function. And so it provides you a little bit of extra safety from the compiler. And at runtime, there should be no overhead for using a new type. Like it would be just as if you were using a string. So new types are pretty handy. The only thing about new types is they can only wrap like one thing. Like you can only wrap a string. You couldn't wrap like a record of strings or something. All right. So anyway, we can derive instance new type first name underscore. Oh, new type. Oh, okay. Probably need to bring in this stuff. And I also think, oh, we're not using unwrap. That's fine. we'll use it here in a second probably. Okay, so we derive instance new type first name. Okay. We did that. Then we have a last name. Okay. And then we have a full name, which is a first name, a last name to produce a string. Yeah, so like this is where you kind of have to you start to like I guess like lose the type safety a little bit because in this particular example, there's nothing stopping you from flipping first and last, but at least you know that this is a first name and this is a last name. So your functions still have to be implemented correctly, but at least like you can't screw up the first name last name ordering. That's like of the inputs. You can screw it up in the output, but I suppose that's why you would have a test or something. I think I would probably write this more often than I would write the actual data constructors, but I don't know. Okay, so you may think this isn't worth the trouble, but when we don't know the exact type, it becomes much more powerful. Oh, interesting. I've never seen this before. So you're saying, like, given any new type that wraps a string and any other new type that wraps a string, then you can just write, like, last name first. Interesting. That's cool. I didn't know this was a thing. Definitely want to write this down. So glue new types. I don't think glue is probably the right word. Combine new types. Combine string new type. To be fair, I don't know how when I would use this offhand, but it's neat. So new type A string. New type B string. Um, so that's what goes in between. Neat. Very cool. I didn't know that was the thing. I don't know. Like, I don't think this is a great example for this because of how simple these functions are, but I'm kind of wondering if there's more clever ways that you can use this that I can't think of offhand. But now I know that it exists and that new types are basically just constraints, which is pretty cool. I feel like I didn't understand this about new types when I was working with them before. Mm-hmm. So we need to derive that it's a new type, and then we can derive its eq instances. And I'm guessing that these just go through the new type because it knows what the new type is or something. Okay, so let's wrap something more complicated than a string. Wait, this can be a new type? I guess it can because it doesn't have any type instances and it's like a single record. That's pretty cool. Okay, so we're just gonna replace our person with new type, and I think everything else like should just kind of work. Okay, and then what are we trying to do? Okay, so we're trying to write. We have this instance as address CEO where, so we're gonna have um get address CEO person P. I'm guessing that's gonna compile. I wonder if we can write like a way to handle this for generic CEO gen tor. Okay. Oh, sure, we can do that too. Because we already have a person instance, which is fine. Um, I kind of like that better actually. It just looks. This is probably where they're going with the new type thing because these are new types. We can probably just derive these things. Let's find out if we can. That would be really cool. I'm not going to look forward. I think it just says that we could write it generically, but I'm bet you. Well, I don't want to delete this. I wonder if we can just derive it via a generic instance. So we need to first say derive instance new type CEO underscore. Then we want to derive instance has address CEO. Okay, so it says that it's not derivable, which is fine. I think what this next thing is getting at. Yeah. Okay, I see where we're going. I didn't get it at first, but I get it now. Generic person. A person. Oh yeah. Okay. And then since we have those, we can just say instance has address CEO where get address equals generic person has address, right? Yeah. Cool. So I want to write. So normally I wouldn't write this much down, probably, but I've actually not done this in PureScript before. So I think it's a good exercise to just write it down once. Like that repetition helps bring it into your brain. Oh, okay. So we just need to. Cool. What time is it? Okay. Um, how much longer is this? Okay. Well, let's just finish this little section. So yeah, here's this version that uses the new type class and a generic uh person instance using the new type constraint, which is super cool. Um oh, okay. There it is. I knew I figured there was a way to do this. I just didn't know how. So sort of let's write this. So one option is to use this generic function to unwrap and get address for the new type. However, there is also new type deriving. Very cool. So let's just put this here and that there. And that way we can add some space in here. Okay. I cheated. I don't think it's cheating. Oh, well, okay. We haven't seen this before. But there is new type deriving in Haskell as well. So this is pretty cool. Yeah. So person has to have the has an address instance, otherwise we would have a problem, which makes perfect sense because it's using the fact that this new type exists around the person. Okay, so that gets us to overlapping instances, which we'll deal with. Oh, right, that's not there. Which we'll deal with next time.